Thank you everyone for joining. So today, this is the Northwestern CIERA REU, and it's our annual career panel. Happy for everyone to be here. So in the room is the CIERA REU students and other Northwestern Research Summer students. Happy to have everyone here. And we are joined by our wonderful remote panelists today. We'll go around and introduce and have everyone kind of give about a 5-minute intro in just a second. But just for some logistics, so for everyone joining remotely, welcome. We're very excited to have you here. If you wouldn't mind, go ahead and putting an institution in your Zoom name so we can see where everyone is from. But thank you for joining. We're very excited to get going. So a little context. Most of the participants on this call are doing research either as an REU or another research program this summer, mostly in physics and astronomy. And through those opportunities, you all have a good chance to kind of get to know what professional research in academia is like, both from, basically your cohort and seeing their research projects, but also learning a lot from your mentors. But we always like to have this career panel every year to basically have an opportunity for people to kind of see what else you can do with basically an academic career, getting a PhD, and what other kind of jobs people can take on. We are joined today by a wonderful panel. So all have gone through PhDs and earned PhDs, mostly in physics and astronomy. But maybe Arena, I will start with you as our electrical engineering PhD to just give a 5-minute intro, and we'll just kind of go around the horn as we go. So Arena, I'll start with you. Thank you.
Sure, thank you. I'm so glad to be here, especially since I'm not a bona fide physicist or astronomer. But I completed a PhD in electrical engineering at Stanford University in 2019. It took me about 7 years. It was kind of tough. Half of it was in biophysics and the other half was in bioinformatics. So my area of electrical engineering was more about signal processing, which overlapped nicely with some of the biophysics that I was doing, as well as some optics, which feels a little bit more physicsy. And the bioinformatics part was very much signal processing. During my PhD, I got to do some teaching, which made me realize that I quite like that. And around the same time, I realized that I kind of liked talking about science more than I liked actually doing it. So I took a science communication class. It was about science writing. We got to meet radio hosts like Joe Palca on NPR, and it really got my gears like going about thinking about life outside of academia. In addition to that, in 2016, there's just a lot of stuff going on politically, and I started thinking about also issues that were outside of academia. And Stanford was quite savvy. They, saw that a lot of people were suddenly very interested in democracy, and they created a data journalism class that I participated in. And through that, I met some former investigative journalists, and I realized there that the curiosity that had taken me to a PhD, that curiosity was mostly about, the natural world and engineered systems that humans could create. It was slowly turning into interest about systems and institutions that humans had created for ourselves. And I got really interested in accountability, questions about transparency and just like how hard it is to be informed as a citizen, even one, in the middle of a STEM PhD program. So I decided to finish my PhD. I kept taking journalism classes. I took some student journalism programs and ended up doing a 1-year master's in journalism after my PhD. A couple internships. I was that like 29 or 30-year-old intern at a couple newsrooms, and eventually found my way to ProPublica, where I was an investigative data reporter for about 4 years. And last March, I joined the New York Times because I wanted a change of pace. So I'm here today, and I'm very excited to hear your questions.
Thanks for joining. Hannah, can I have you go next?
Yeah, sure. Hello. I am from the UK. You might be able to tell from my accent. So yeah, I that's where I started off my career. I did an undergraduate in astrophysics in the University of Southampton, but I spent my final year at Harvard, which I'm sure many of you know. And then following that, I did a PhD at University College London, and in that I really specialised in astrochemistry, understanding the kind of fundamental chemical makeup of the universe, and connecting that to the star formation, planet formation, even life. And then following that, I was kind of on the academic circuit for a while. So I moved around from different postdocs. I was in Denmark for a period of time at the University of Copenhagen. I went off to Chalmers University in Sweden, where actually that's where I met Mark, and did some research there for a while, and then eventually ended up in Poland, the Nicholas Copernicus University, where I was leading a research and science group of students and scientists trying to discover fundamental chemistry within the universe. And this was great, a real foundation in statistics and understanding how planets and stars form. But after a while, I felt the need to go home back to the UK, and wanted a bit of a change from academia. So I decided to switch out. I tried a few different jobs in between academia and finding what I do now. So I was investigating gaseous emissions from the Earth to kind of map and reduce map climate impacting gases and reduce the impact on climate change. Obviously, an astronomy background that particularly observations and that kind of statistical data can be very handy for that kind of career. And then I moved on to what I do now. So I work for a company called Eclipse, and we partner with some of the largest brands in the world, trying to help them apply more kind of scientific methodology to how they analyze business and different numbers to drive their customer experience, their revenues, to really make their websites and their platforms, the apps on your phone, much, much better to improve that. And a lot of that work derives from the kind of science and the statistics that you do in physics and astrophysics. But you'll find in business, not everyone is always very au fait with statistics, and there's a lot of bad practice. So we kind of come in as the experts and really help them do better, and we're able to drive a lot of better business, more money, but also better accessibility and user experience. And that's really what I do now. I'm excited to get any questions that you guys will have for me.
Great, thanks, Hannah. Matthew, how about have you go next?
Sure. So my story about where I got to probably starts in undergrad at Loyola University, so just a little south of you all. While I was there, I did made sure I did an REU like every summer. So I, highly think that the REU program is great. I highly recommend all of you students just do as many REUs as you can. It's great to be exposed to just different institutions, different areas to work, and even different geographic areas to be. And so one of the REUs that I participated in was with the Naval Surface Warfare Center in Cottle, Maryland. And so that was where I was kind of exposed to the intersection of just basic science. I was measuring stress and strain of magnetorestrictive materials with supporting the military. So the idea was that this research would potentially go to support the Navy. And I never was willing to join the military. But I have an appreciation for those who do, because they sign up, and if the military says you're spending a summer in the deserts of Djibouti, or you're spending a year underwater on a submarine, you're doing what the military says. So that was one of the big reasons I didn't want to join. But I can appreciate kind of supporting them from an academic side. So after that, went to DePaul, got a master's there. That was a whole separate side story regarding the physics GRE. If you have questions about that, we can delve into that. But eventually, I went to Northwestern, got my PhD there. While there, kind of decided I didn't really want to stick around in academia, and happy to answer questions about that too. While I was kind of searching, and this is why I think this panel is a great idea, because a lot of the people in academia don't really know how to help you find jobs outside of academia. And so I was struggling a little bit to find places that I would fit. And honestly, what ended up working for me was there was just an email going around the department. And so I responded to that email, and now I'm here at the Institute for Defense Analyses. So this is a non-for-profit. It's actually a unique non-for-profit. It's called a federally funded research and development center. There's about a dozen of them in the country, and they're unique because we can only work with the government, whether it's local, state, or federal. And that puts us at a position to provide unbiased reports, whereas some other non-for-profits, like they might receive funding from businesses. We don't. So if we're going to put out a report on this is the capability of this airplane, you don't have to worry about that. Maybe we're getting kickbacks from the people who build that airplane. So the work that I do is we evaluate the new military systems. So by law, new military systems of a certain cost or certain importance need to be evaluated and their capabilities reported to Congress. And so I support the government in doing that. So I will help make recommendations on this is how you should test. Then I go out and I'll observe the tests and analyze the data and put forward an input report on this is what my recommendations on the capability of the system. And that report changes a couple hands and maybe gets edited, but eventually parts of it will go to like Congress or to the chief of the Navy or the chief of the Air Force. And so it's something that I find valuable because I would much rather have us test these systems now in a safe condition and then report on it, as opposed to our servicemen and women finding out about the capabilities when they're being shot at. And I don't know how many of you have been paying attention to the news, but some things have been going on recently in Iran and the Straits of Hormuz. So it makes the work that I've been involved in very relevant. And so looking forward to your questions. And if you all are really interested, we also have a summer program that you can apply for next summer. So looking forward to the rest of the discussion.
All right, thank you, Matthew. Julie, can I ask you to go next?
Sure. Hello, I am Julie Halleck. My journey through astronomy to where I am probably started in high school. So I got to participate in the research-based science education program out of Kitt Peak National Observatory, which I think might be called something different now. And I actually got the opportunity to go to Kitt Peak and like do an observing run when I was in high school. And after that, I was like kind of hooked. I'm like, yes, observational astronomy is super cool. I went to Michigan State for undergrad where I majored in astrophysics and physics. Like Matthew, I did REUs every year, and they were in and around stellar spectroscopy because I thought that was like super cool, like another form of signal processing, where like you kind of go out, you take what the night sky gives you, and you mine that signal for physics, which is I think pretty neat. One of my REUs is at the University of Texas McDonald Observatory, and that was like one of the best summers of my life. And it was so cool that I ended up going to UT for grad school, where I studied the chemical composition of metal poor halo stars to try to understand like what the early universe could have possibly looked like. Towards the end of grad school, I kind of realized that like I probably didn't want to stick around in academia. And so like a lot of my grad school cohort was like looking around and like seeing this data science thing as like this new this is like in 2014, this like new like field of like, oh, there's like a lot of possibility, but I like didn't necessarily have a great time in grad school, so I wasn't sure that that's what I wanted to do. So I did a coding boot camp for web dev, and so I went there. It was called Hack Brain Academy. It was meant to get like more women in tech, and then I started doing my interviews, and like I got in with a company which was like ironically called New Star, since I studied old stars, and like when I talked to their VP of engineering, he was like, "Oh, I want you to talk to the science team too." And it was just so much more interesting. It was like an ad tech problem. It was like detection of like trying to figure out like what was going on weird in their data sets. And like it was like, okay, this is like more like take data and then try to like make meaning out of it, similar to astronomy. So that was like a super transferable skill, along with like kind of some of the statistics work that you have to do in astronomy. I think it translates really well because astronomy data is like messy in ways that like other kinds of data aren't. I was at Newstar for a couple years, and that was where I first went to the SciPy conference, and I really loved it. It was like a really cool confluence of like industry, academia, and government, and you could meet people who are building like all of these packages that like you use day in and day out. And I started volunteering for them. And so that has been kind of like a through line of like open source and scientific computing throughout my like career trajectory. After Newstar, I worked at Twitter. Twitter, RIP, was a platform that I really loved, and I worked in trust and safety. And that's like anti-abuse, like anti-spam, anti-misinformation. And it was like important to me because it was a product that I really loved and used. And trying to make it safer and better for people so they could get the same cool experience that I had was neat. And something that I've noticed is that there are a lot of astronomers that make their way into trust and safety. Like I have conversations with folks who are like, oh yeah, I got a PhD in astronomy from like such and such. And actually somebody I went to UT with did do trust and safety at Facebook for a while. After Twitter, I went to Mozilla, where I got to really nerd out on the open source stuff, where I was director of data science, and I led the organization to like really try to understand like users in privacy preserving ways. And that was neat. And now I'm at Humane Intelligence, where I'm chief technology officer, and we are a nonprofit where we do AI test and evaluation with a goal of like letting organizations like use AI for social good as opposed to social bad. And so I'm happy to like answer questions about that. Like SciPy being kind of like a through line in my career, I eventually volunteered so hard that they asked me to co-chair the conference. So I co-chair the conference for like 3 years. This is the first post co-chair years. I'm very excited to go next week and just like participate as opposed to like run stuff. I'm also president of the board of directors of NumFocus, and we're an open source scientific computing fiscal sponsor. So we put on events, including the SciPy conference and also PyData conferences. But like more importantly, we help do like administration and business stuff for open source projects. Like you may have heard of like NumPy, SciPy, Matplotlib, AstroPy, SunPy. And I'm also an inaugural member of the CIERA Tech Council. Yeah, that's it.
Julie, thank you. And Chentao, welcome.
Hello, yes, thank you. Thank you for inviting me, and it's very happy to be here. So actually I'm the type of person that grew up with a dream to be an astronomer when I was very young. So I was like always fascinated with the documentary Where I See All the Planets. When I was like very little, I was hooked, and I say I want to be an astronomer in the future when I was like probably 5, 6 years old. So not surprisingly, I chose astronomer as my undergrad. So I started with astronomy undergrad, and then I went to the master of astrophysics all the way. And there, back then, it was around 2013. I started to know like the development of ALMA. If you know ALMA, like the one of the most it's the most powerful radio telescope that we built on Earth. So I have the dream like I want to work for ALMA. I want to be a radio astronomer. So. And then I moved to Paris to do my PhD. So I did my PhD there, and after I finished my PhD, I ended up in the European Southern Observatory. So I was spending 4 years in Chile, and there I got to work with for ALMA. So I have like 50% of my time to do research as my own wish. So I have a lot of very generous funding, so I can have the full independence of my research, and another 50% I need to work for ALMA to do some duty work. So it's kind of like, I had my dream came true like when I was very early phase, and now I've really worked for ALMA. So after the 4 years, it was a difficult time to choose job because of like pandemic time, and it's very hard for job market, and it's the same for the postdoc. So luckily I got the postdoc in Chalmers, so in Sweden. where I also met Mark, and where also Hannah was earlier before me, but she was also in Chalmers. And then I spent years and 2.5 years working at the Chalmers Department of Astronomy, doing astronomy stuff. And then I met someone in Gothenburg. So I have like kind of like my personal choice. This is a situation that I have to choose between my personal life and career. So in that sense, I chose my personal life. So I decided to stay in the city. I also like Gothenburg very much. So I made a choice. I want to stay in the city, and then I have to sacrifice my career. So I'm starting to look for alternative career choice. But on the other hand, I feel like it's not like a dream like being killed, but it's more like for me is there is a much bigger world outside astronomy as well. So there are many interesting things, as many previous panel members has mentioned, that there are so many interesting and maybe very useful things that you can contribute to the society, to this world. So I also started to look for other jobs, and I ended up with a company called Jeppesen, which is building software for commercial airlines. So that's what interesting for me is that there you have to, it's a lot of like problem solving. Um, we build softwares for like big commercial airlines, including like Lufthansa, Delta, United, all the big ones you heard. And there are many interesting mathematical problems and also programming problems that you can solve with them. So it's kind of challenging for me, but it's also interesting because I like solving problems. So that's what I'm doing now for almost 2 years. And I'm still exploring like my interest and what I can grow and what new things maybe I will be interested in other new things. But yeah, that's my career. Thank you.
Great. Thank you, Chantal. Thank you, all of our panelists. So we will dive in on kind of like opening up the floor for questions. So for those of you joining remotely, I encourage you to put your questions in the chat, and we'll sort through those and call out those questions as they come. For those in the room, start thinking about your questions. But before we dive in on questions, maybe so all the panelists, you all gave a great introduction to kind of your path and your current positions. But can we hear a little bit more about your current day-to-day? So I'll pick on Arena and kind of go in the same order again. But yeah, just kind of what is your current day in your current position look like? What kind of skills are you making use of? How does that connect back to kind of things that you've learned in your education, or are they totally new? And yeah, we'll do kind of one more loop through before kind of opening up for broad questions. So think about your questions now, start putting those in the chat for those remotely, and we'll hear from each of our panelists. So Arena, I'll let you start again.
Great. And I realized I don't think I said much about what I actually do as an investigative data journalist or a data journalist. So let me just, I'll blitz through that real fast. Yeah. So as a data journalist, a lot of people I talk to, are surprised. They're like, I don't know what that is. And so I like to joke that if you ever read a story and it has somewhere a sentence that says, like, according to a New York Times analysis, like X% of Y group saw Z effect, that's what I get paid to do. And it's often not a ton of words. Sometimes might even turn into like a bar chart, but it's a lot of work and a lot of spreadsheets and a lot of structured data. So yeah, essentially my job is to analyze data. Sometimes it's structured and clean. Sometimes we have to get it ourselves. But essentially, I need to get that data. I need to clean it. I need to understand every single bit of it. And then I need to analyze and see if it, I need to check if it aligns with what my colleagues and reporters who are, the traditional reporters are finding or hearing on the street. If it's not, it's my job to help them better contextualize the stories that they're writing. And in some cases, my data analysis may actually point them in a completely different direction. So what does my day-to-day look like? It's a big mix. It is often either coding up an analysis pipeline, it's often literature review, and I would say the other big thing I tend to do a lot is talking on the phone and interviewing experts. And then some small proportion, I also get to talk to and interview what we call sources and characters and stories. So yeah, it feels sometimes a lot like my PhD in that I will have to do a literature review and look for a bunch of articles where experts have already done the analysis or done a similar analysis to what I'm thinking about. I'll call them up, I'll schedule an interview, and I will ask them a billion questions about, pitfalls that I might not be thinking about, whether my analysis ideas make sense, is it statistically significant, all that jazz. And then other days I'm just coding all of that up. A lot of times I'm in meetings with reporters trying to translate and communicate my findings and to make sure that we're all on the same page about what the numbers say. I think a lot of my job is also just, to that, to an extent, like science communication and science sort of, I would say quantitative understanding. Um, and does this, oh, okay, so as far as skills, that's at a high level. I think a lot of it is familiar. I'm using Python. I learned how to code in grad school. Um, these days, we're also using a lot of AI tools. So we're using Cursor and all of the agents and models that are suddenly very exciting. Um, and I would say that a lot of this feels familiar and a lot of it feels like skills that I used and got in grad school. Um, I would also say that a lot of the skills are not necessarily the hard ones that I learned. Learning to manage up, learning to manage laterally, um, putting, creating sort of structure in an otherwise amorphous problem has been a really important skill for me. So, yeah, it's sort of a mixed bag, and every day is a little different, and I like that a lot.
Great, thank you. Hannah, what does your day-to-day look like?
Yeah, so my day varies a little bit with the season, much as it did in astronomy. So one of the big kind of events in my calendar in astronomy was telescope proposal season. So I did a lot of observational astronomy. So there's a few points in the year where a big telescope allows us to compete for time. So it's furiously writing text, trying to get the data and the arguments there to convince someone to give us a lot of telescope time, and that's very much a lot of what I have to do in my current role. So we are either writing proposals to offer our services to clients, to public bodies. So it's kind of writing a lot of text to convince people that we offer the best skills and services to help solve their problems. It also feels very much like running a large team of people. So my team, I've got a team of developers, designers who work together to create better digital platforms for business, and that requires especially last minute things like Black Friday. Black Friday is a short event. It requires a lot of changes. You'll see visually on any website that you go shopping on. You'll see lots of visual changes, lots of things happening. We are coding and designing a lot of that content and supporting our clients to drive massive amounts of revenue during a very tiny period. So it requires kind of very quick organization, quick decisions, and organizing lots of different people together to kind of move as one and develop really big quality. One of the kind of golden rules is if you break the client's website, don't do that, because you do that, they're not making any money over the night because you stop their checkout working. One of the other things we do day to day is we create a lot of what's called A/B tests. So these are tests that you probably, while browsing around shopping, have found yourself in without even realizing. So an A/B test would be you've got a current state control of a particular digital experience. You change a little thing on that website. It could be the button color. It could be the entire redesign of the checkout, and you see if that drives more customers to buy. So I do a lot of the calculation of the science on that, make the decisions day to day on how to protect the experiment so we can be sure that our results are scientifically valid, and therefore we're going to fairly inform the business statistically that if we're going to ship this as a permanent change on the website, that impact is going to be a positive long term. And that's kind of dealing with those kind of statistics is a big part of my day to day, and kind of something I really honed while doing astronomy that I've picked up in business. And then I think also just talking to people, I found in astronomy being able to talk to people and network and communicate and be good at that was essential to what I had to do in that role. And that certainly has helped me a lot while dealing with clients and devs and designers who all think slightly differently. And you have to kind of be able to adapt and communicate well. So that's kind of a rough idea of what I do on the daily.
That's great. Thank you. And Matthew, how about you guys?
So fortunately, unlike Hannah, I don't have to worry about proposals because the military keeps buying things and Congress still wants to report on them. And that was kind of one of the reasons I wanted to get away from academia. I liked the comfort of always knowing like I'm still going to get a paycheck. It's not going to depend on whether or not my proposal does or does not get accepted. But most of the day-to-day is meetings, but it depends on, the meetings vary. The interesting thing that I found, kind of coming into working with testing of military systems is that the cadence in terms of the timelines can be much greater. Like Hannah was mentioning, every year you've got, proposal season for what, the next year of observing on a telescope. But it takes a while to build an aircraft carrier. And so there's a lot of lead time. And so like yesterday, I was on in a meeting where we were working on planning testing for like 2 or 3 years from now. And these tests can be, expensive, multi-million-dollar tests. And so we want to, and they have a lot of moving parts. So part of it is, you know, discussing how you want to test the system, how it should be tested. And it's interesting because I'm now exercising a lot more of like kind of like the soft skills of the negotiation, the active listening that you're just not really formally taught. Because, if I'm going to say, hey, I recommend you do 3 runs, well, people are going to be asking, well, why not just 2? Because removing 1 run will save millions and millions of dollars. And so you have to be like, all right, you can do that, but now your uncertainty and your capability is, going to be potentially large that you won't even know. So having those sorts of discussions has been a big part of my work. But then also because of that, of those long timelines, like there's periods where you are working on prepping and planning for a test, but then you're also going out and observing tests. And so that's something that is, many ways wasn't something I was ever expecting to do, but it is an exciting thing. Not many people can say that they've, been on the deck of a U.S. Navy destroyer and watched a missile fly out. And so it's something that I find, exciting, because it puts me in perspective where a lot of people, just don't normally be. And then then you're now collecting we don't collect the data, but I would receive the data. So again, doing data cleaning and then potentially also negotiations of, oh, your data is in this unique format that only your proprietary software can read. So can we get that software? Oh, no, we can't. All right, let's come up with some working relationship on how can we at least get the data in a format so that then we can analyze. And then it's, analyzing the data and then writing up. And so what I've actually found that I've enjoyed a lot is the writing. The writing I do is a lot different from academic writing because you're not writing for other academics, and you're writing for people who have very short amount of time. You're potentially writing for, a 4-star general. They do not have a lot of time to read through multiple pages, so you need to be very concise and to the point. And that's something that I appreciate more now, and I feel that academia doesn't do as good of a job of teaching and training of how to be very succinct in our writing. And so that's kind of been a lot of the skills that I found, and also just like figuring out what tools work best for you. So we're in many ways given the freedom of you want R, Python, MATLAB, pick your favorite flavor. And the AI is getting big into it, but it's also interesting because there's also a lot of restrictions. You have to acknowledge like, hey, AI, if you put a bunch of information into it to train it, maybe it finds out in things that you don't really want adversaries to know. And so it's very interesting also dealing and working with restricted information that you just can't share with others. And so that provides a bit of a hurdle that has to be overcome, but it still makes it an interesting work environment. So
Great, thank you, Matt. Julie, up next.
Yeah. So I would say like I think one of the biggest things that I learned in astronomy, especially in grad school, is that like you own the whole process, like every step. Like you come up with an idea, you figure out how you're going to test that idea. There's a data collection step if you're an observational astronomer. So then like I think Hannah mentioned it's like the grant writing, the proposal writing to try to like get it, then like actually getting the data, doing the analysis, building the tools to do the analysis and like going to conferences and presenting it. And so like that whole like life cycle I think was like really important. And throughout my career I've used different like kind of aspects of that at like a kind of small nonprofit where I'm at now. My day-to-day is like varies wildly, and I like that. It's like not all the same every day, so I don't get bored. A lot of the grant writing comes into play like as a nonprofit. Specifically what my like organization does is that we do AI red teaming. So it's a lot of like interrogating a generative AI model to try to figure out, is this doing things that like we expect it to do or don't expect it to do, right? Like so if we're working on something, we want to make sure that it doesn't show gender bias or age bias or racial bias, and like knowing how to frame like scientific questions, like I think is like really important. I do like most of my stuff is in Python. That is not a skill I learned in grad school because I learned Fortran, but hopefully all of you will be spared from that. SQL is also like a skill that I didn't necessarily learn too much in grad school, but it is very important, I think, in data science. But I think like kind of just in general, like the things that I learned, maybe like there aren't specific astronomy things, but like more general, like being curious, having messy data sets, like all of those have served me really well in data science and in kind of like the AI machine learning space.
Great, thanks, Julie. And Chen Tao, bring us home.
Yes. So in my daily work, so we started our work by getting requirements from our customers, so the commercial airlines. For example, like currently where I'm working on a project with Lufthansa, so the beginnings is that we need to talk, we need to communicate with customers that what they need. So this is quite important that you have the communication skill. You need to understand they may have tell you something they want, but you have to translate what they need to what our system can work. So kind of like a communication skill that's important. And then you come up with a solution, like how we're going to solve this problem. And I think this is quite important, that is you have this kind of like a structure thinking that like you have to solve in what kind of steps, and like have an overall structure and how to test it. Like it's kind of like what currently you're working with these AI agents, like you have also kind of workflow. This is the whole structure is quite important. And then you also need to have analytical thinking. That's also, I think that's we've been trained a lot as astronomy education. I think there are many, basically in science, that it's quite important skill that you're going to train, and how to solve the problem. And there you need a lot of logic and understanding of the programming, the data, and how to do testing, those things. Unfortunately, I was not educated as computer science background. I was also having a Fortran educated, so it's not useful to my job. But luckily, I have. So we have been some experience with Python, as everyone do, and also because astronomy, a lot of things open source. You are dealing with open source softwares, and you need to use a lot of Linux. So when I was undergrad, I made my mind to use Linux and just totally toss the Windows. So I just installed Linux on my personal computer. And I remember I spent 3 months to make my computer work, just the sound card to work. So it was very painful. But I learned a lot. So that's also quite important. Actually, it helped me a lot during my daily works. And lastly, when you have a solution, when you solve it, and you need to present it to your customer, like how this is working, you need to have a presentation, you need to have a proper documentation. So this is also actually mapping to what we actually do in science, like specifically in astronomy, that you need to present in conferences, like what is your science research results. That's quite important. The lastly, I think one of the core skill that I think many companies will value very much is the teamwork, like how you're working in the team. And that's also one major difference is, I mean, it's kind of different, but also similar to how we work in academia. Like when I switch from academia to my current job, I feel like the teamwork is much more valuable inside the company. Like how you work with different people inside team towards the same goal. That's very important. While in academia, you need to work also in the teams, but also there are a lot of competitions. So that's slightly different dynamics, but also like teamwork is really important. How, especially when you have different opinions, how you can move towards the same goal rather can reconcile that you have differences. So that's very important. Yeah, thank you.
Great, thanks, Chinta. All right, give an opportunity for folks in the room. Raise hands, any questions? Interesting follow-ups? Well, we have one question, which I thought was great from Miles Bethel, thank you. Knowing what you know now, what skills do you wish you spent more time learning as an undergrad in order to prepare you for your career? Yeah, and so specifically, with this audience of the undergraduate students, how did, do you feel like there were certain things that you could have done in undergrad, or that looking back were really important that you took on during undergrad? Or maybe it was a choose your own adventure, and that path will kind of lead you in lots of different ways. Any panelists want to take that on first?
I can
Yeah,
take it.
Matthew.
So
So
like,
we'll start with Matthew, then go to
oh,
Julie.
sorry.
No, all good. Thank you.
No, that's all right. So I definitely think communication is really important. And so while I was an undergrad, I did a lot of kind of like science outreach and public outreach. And so being able to work and describe your things to the public, I think is very important. But one thing that I think I missed out a bit on was how to write it. We a lot of courses and a lot of research involves presentations, whether it be a poster or a formal presentation, but they don't necessarily involve writing something that is short and concise and to the public. So I think that would be something that would have been more useful for me. And then the other thing, just in general, is like figuring out how to negotiate, both from a very basic life skill of, like I'm getting foundation work and being able to talk with contractors of, no, I think that's actually too much, or let's do this or that, all the way to also professionally of, people have certain views on, like, oh, we don't want to pay as much for this test, but you're like, well, okay, but this is what you're going to miss. So I think a lot of those soft skills that just aren't formally taught, that you would just get from being involved with a variety of different activities, I think that would is very useful.
All right, thank you, Matthew. Julie.
Yeah, so one of the things that I did in undergrad that, like, looking back, I could have done a lot differently. It was like I was very single-minded in that, like, I will be in astronomy, I will go the tenure track route, but like it wasn't until grad school where I'm like, this isn't the right path for me. But I took almost only math and physics classes. And if I could go back, I would do something a little bit different. Like undergrad is the last time where you can take something that like isn't part of your major and like actually like explore things and sort of like expand your knowledge base just for like the joy of learning. And I think that like it makes for a more well-rounded like experience. And so some of the classes that I did like kind of like I was just like, well, I need more credits to graduate. I took a speech class, and that was pretty like important actually. And it was like Toastmasters like person. It wasn't even a professor. It was a guy who ran the local Toastmasters thing. But it was good because it like gave me kind of like it put me in front of an audience that wasn't just like a bunch of scientists. And then the other thing like that would have been helpful, or like I know I said like you don't have to just do math and physics, but like more stats and more like linear algebra, as opposed to just trying to like pick up the math that I thought was important for my branch of astronomy, like would have been nice. Because like I think that like for my day job, what is actually really important is being able to like break apart problems, and like secretly the layer that like people don't like realize is like it's all math underneath it. And then like it's like how is it applied in these different areas? Yeah.
Great. Thanks, Julie. Yeah, Arena.
I want to echo a lot of what Julie said, and the way I'd phrase it is, my own personal journey was I similarly didn't realize until I was like, what, over a decade um, into engineering that I was like, I'm not sure I really love doing engineering for engineering's sake. Like, sure, I love optimizing as much as anyone else in Silicon Valley, but there were other things I cared about. And so I think that my advice is to spend as much time as you can in undergrad reflecting on what makes you excited, like what makes you really just eager to jump out of bed and work on. And I think had I listened to that a little more, maybe I would have gotten into journalism faster. It is to my chagrin, I realized that MIT, where I did my undergrad, has a fantastic science writing program. And like maybe I would have stumbled into science writing. But in addition to that, I don't really regret my trajectory. I think I learned a lot along the way. And aside from like shortcutting to my current job, I think it could have also been really cool to take classes in data science for social good. I think that is a field that really emerged after I left undergrad. And I think it would have trained me really well for the sort of analysis I do now that's sort of at the intersection of social science and, hard, like technical, rigorous analysis. Sociology classes and I think econ classes also would have been great.
Hannah.
Yeah, I've got a couple. I mean, and maybe you need a bit of time to learn this first one, but it's knowing when it's good enough and not perfect. A lot of what I've worked on, whether in academia or not in academia, it's easy to get deep into a project and want kind of come up with the perfect solution. When you work in business and kind of when you get more senior in academia, you don't have time for that. You have to get deliverables done. The world is not going to wait for you to publish a paper or come up with a great result. Someone's going to do it first. Someone's going to, get the project over the line quicker in business, and it's going to kind of hold you back. And knowing when to just go, this is good enough for what we need to do, and not always try and strive for perfection, I think is one of the big things. And then the second one is finish learning Swedish, which I know may not necessarily be the kind of thing that everyone. It depends what countries you're near, but I find myself often in a lot of London-based events, but quite international, and having that kind of extra edge. Like people say to me, "Go and speak Swedish to someone." I'm like, well, I can understand some of it, but not being able to kind of have a novel, interesting way to kind of strike up a conversation with someone as a potential client is a trick that I missed because I just didn't finish my studies. So if you know another language, it can really help you in business.
I'm actually going to do one quick one from Shrey Gold. In your views, PhD being a valuable investment of 5 years versus getting 5 years job experience. Yeah, now looking back at the different trajectories people have walked, and the fact that you all have kind of chosen something away from academia, I think maybe one way of putting that is like, was this always the path? And oh, maybe it would have been better to find that sooner, and you would have been happier, or what did doing a PhD in this investment of years and experience, was that, looking back, do you feel like that was worth it still? And Chentao, we haven't heard from you in a little bit. Maybe I can put you on the spot.
Yeah, so actually I've been spending much more than 5 years. So I did 5 years, actually longer PhD plus a postdoc. So I've been research for more than, let's say, 10 years of my life. It's a very substantial time of my life. And actually, I think it's very personal. Like, it really depends what you want. Like, for me, it was my dream when I was young. So I want to do astronomy. So I'm very single-minded. Like, I want to get a tenure track, and this is like only thing that I see. So I've been having a tunnel vision, and until like I met someone and I see, oh, I need to think about like my personal life, and there are many more interesting things on this earth. Like there are problems there are a lot of interesting things that you can solve, like the problem, like maybe you can use it doing some data science stuff, like help the climate, and maybe some you can help solving some political issues with your skills. But actually, what we've been trained for, like the problem solving and also the programming skills and all these things are actually quite useful for me and for people. Like it's some of my friends who is now doing like some data analysis for some satellite image to find what kind of like agriculture study, like what kind of trees are growing good and what is like it's really doing something really good for the climate. And he's actually transferring what he learned from analyzing images, like what he's been doing in astronomy, to now analyzing for the good of climate. So I think it's deep down, it's really personal. That what do you want? Like, do I evaluate this time of 5 years to be like an investment, and in the future I want to look for a good job, or it's like part of my experience of being alive? Like maybe in the 5 years you contribute a little bit percentage, like maybe 0.1% of the growth of the human knowledge of the universe. That's really beautiful. Like that's very significant. And this is invaluable. Like you cannot value this like in amount of money or I think this fact in itself is already something that is truly like you cannot value with anything. But if you want to say like I spent 5 years and I want to, it's kind of investment. I want to find a good job. I want to have a stable family, whatever. Those things, I think maybe in that sense you need to like carefully like to evaluate it. Is really worth it? Maybe in like, am I looking for some jobs that maybe they can also transfer some of the skills that we have learned in astronomy, and maybe also take the course related, and also you kind of develop yourself still in the frame of like the science program that you're choosing, the PhD, during the time the PhD you study, and you can also kind of linked to what you learn and in the future when you choose a job. So it's kind of like you can still weigh in the sense of like more practical purpose. So for me, I think it not more than 5 years I spent. It's already I already leave my mark in the human, how to say, it's kind of like egocentric, but I leave the mark on the human knowledge. Or like I move a little bit of this. If you remember, there's a picture of this circle. You move a little bit of, you pinch a little bit of moving forward of our knowledge. So that itself, I feel it's already worth it for me. So that's my answer. Thank you.
That's great. Questions from the room? Yeah, Rebecca.
Would you say it's easier to have a work-life balance when you're not doing that, or is there trade-offs for both sides?
Were panelists able to hear that? Okay, yeah, I'll repeat. Yeah, I'll repeat for folks, my low booming voice in the front. Rebecca was asking, do you feel like work-life balance is easier to achieve in industry versus in academia? Nodding heads.
Maybe one thing I will say is that the thing that's consistent between academia and industry is that you are there. So like it just kind of depends on how you are as a human. And so like if you're naturally inclined to like good work-life balance. Like one of my best friends did the UT REU with me. He's great at work-life balance. I am not. And so this has followed me everywhere. So it's, yeah. Sometimes it's like the job, but sometimes it is you.
Basically, Hannah.
Yeah, I would say work-life balance for me, I didn't learn that, not because I was in academia or industry. I learned it because I lived in Sweden and Denmark. Those countries, it's the most important thing in their daily lives for everyone. And it taught me to put down the computer, to go outside and I've never been more productive in my entire life and I did the best science of my life while working in those kind of environments. And I took that with me back to the UK where we don't always have a great work-life balance. And then it was about finding the right company that respected your time, and it was healthy, right? You can work in a lot of places that won't have that impact on you. So I think it's just, yeah, you got to be strong and know yourself, and hopefully find the right fit for you to kind of achieve that goal.
Other panelists? Yeah, Matthew.
Yeah, I definitely want to just emphasize what Julia mentioned. It really does depend on the individual, but I do feel it's really important to work on work-life balance, and it's in some ways at least easier once you're outside of academia, once you've graduated, because you don't you don't have your dissertation or your PhD necessarily on the line. I definitely remember when I was writing, it's like, all right, well, I should always be writing because this is, if I don't do this, I don't graduate. And then what was the point of all those years? Um, but I also want to emphasize what Hannah said too, of it's important to also find an institution. So like when you are applying for jobs, it's just as important for you to also be interviewing the potential job. You want to land in a place that you feel comfortable, that you like, that you enjoy. And so you want to try and make sure you find a place that supports whatever work-life balance you yourself want. And so in some respects too, industry kind of helps a little bit with the work-life balance, at least from my perspective, because I'm only getting paid for these hours of work. So if I'm going to work beyond that, I'm now devaluing the salary that I'm getting. So that is a way to help look at it, to help emphasize when you should and should not work. It also particularly helps when you can't bring your work home with you legally.
Leave that restricted information on the other laptop. And one thing, kind of thinking about work-life balance. So in past panels, we've definitely seen some pattern of people wanting to choose where they live as being kind of like a key factor in basically not doing the academic, merry-go-round of, going to where the positions are. Anyone, does that resonate strongly with you one way or another? Being able to kind of like make different choices about living. I mean, Chantao, I know staying in Gothenburg was a pretty important thing. Maybe this is also changing a little bit in the era of remote work. That there's definitely more flexibility in a lot of ways. But any other kind of like personal decisions, like driving kind of the career path and where you've ended up? Yeah, Julie.
This is like maybe related to work-life balance. I think maybe my experience is a little bit different than the other panelists, so that like I worked at like San Francisco Tech, which was like at one point in my career, I was working 80-hour weeks. And like the justification being like, we are paying you like a boatload of money, so just get back to work. And at one point, my daughter, who was like 7 at the time, was like, sometimes it feels like I only have one parent. And that was like gobsmacked me. And I'm like, okay, like something needs to change. And so one of the things that like was important to me at the time, and I think things are changing a little bit now, like with like return to office mandates, is that like we moved from the Bay Area to like back to Austin, because like we wanted to live there and like we were able to do that. So like that was like really powerful because it was like a place where we had a network and friends and like whatnot. Um, and now like I think it's like a little bit tricky, like depending on like the industry you're in or sort of the path that you're taking. Like in tech, there are a lot of remote jobs, but there are a lot of now like kind of like the notion that like you need to be in San Francisco or you need to be in New York or like wherever. And so I think like it is certainly more flexible than like a lot of academic jobs. And you're probably not going to be like, oh, I now need to live in like, I don't know, Tulsa, Oklahoma for this or Norman, Oklahoma, right? To get this like really like cool job. But like there are kind of places where like I think in tech at least they expect you to be. And remote work is like a little bit harder to find than it was, let's say, like a few years ago, even.
Yeah, Hannah.
Yeah, I would say kind of a personal choice was the kind of real thing for me that made me change. I moved to my last academic position in Poland. I moved during COVID. I because of Brexit when the UK left the EU, I had to move to Poland 3 weeks before that happened. Otherwise, I would have had visa issues. So it was COVID. You could just about get on a plane. Everything was closed. I moved there alone. I didn't speak the language. I was incredibly isolated and it was not a good time. And it kind of made me reflect on what I really wanted out of my life because I'd wanted to do astronomy since I was a little kid, and achieved so many big things in astronomy. I discovered new things, which was super cool. I'd seen cool telescopes. I'd climbed up Mauna Kea. I'd done all sorts of great things, and you hit a point sometimes where you think this isn't working anymore, and the state of science in the UK is dismal in terms of funding. So I knew that there was a choice to either carry on this pathway of moving from place to place or choose kind of a personal happiness, and that would require me to leave. I know a lot of people who've left and been uncertain, but I think in the moment I made that decision, I tried to remember the kind of positives of it, but also memorize the reasons why I was unhappy in that moment. So I knew that in the future leaving would be the right choice. And it turned out to be pretty good. So yeah.
Okay. Yeah, Alex.
And just like on that note, how do you balance having like a stable career and finding work that's also meaningful to you, while also like maintaining your personal life? I feel like that's like one of the very hard things about like choosing a career path.
Were the panelists able to hear that? Yeah, I mean, I think it seems like it's a challenge, right? Like, well, and yeah, I don't know if any of the panelists have a kind of particular example of, do you feel like it's kind of like a three-legged stool of, at one point you're optimizing for one or optimizing for another? Yeah, Hannah, go ahead.
Yeah, I mean, I'm not going to sugarcoat it. There are aspects in that are challenging, and some of that is the society you're in, how much support you might have, depending on kind of what your personal goals are versus your career goals. I would say that you can do a lot of great things in your personal life and in your career that tick a lot of boxes, and that is very achievable. But it's also about kind of asking yourself a fundamental question, like, what are the things that make me happy? What do I want to try and achieve in my career? That doesn't have to fit in a neat box necessarily of, an academic position always. And also asking yourself what you don't want to do. Like for a lot of people, they can get caught up in positions that they later on realize just didn't fit with their kind of the things they enjoy doing, or maybe they worked in an industry that they don't particularly morally agree with. There's a lot of variation with that. Understand where your red lines are, understand what you love, and then it is possible to kind of get a balance. Nothing is perfect, but the goal of happiness across multiple areas, I think, is somewhat achievable with caveats, I would say.
Oh yeah, Arena.
I think I'll also add the note that often priorities change, and that's something I wasn't used to. I think I don't know, maybe I can blame it on my STEM way of thinking of like there's always like one answer and it's the best answer, and I've realized now in adulthood and as a human it's like actually there's like things change a lot, and so my personal priorities have changed a lot. And I'll also say that yeah, it's as Hannah said, it's hard to sugarcoat. You often have to make choices. I will say that journalism is another industry where there are mostly centers of like geographic centers where it's helpful to be if you want to pursue a certain career in the industry. And so I'm based in New York City now. But I do think a lot about, family members getting older or family members having children. And so that's something I'm constantly struggling with.
All right. So taking a question from the chat. Varsha from Black Hills State University was asking, when leaving academia and entering the workforce, how did you present yourself so that employers knew your degrees in physics were applicable to the job? And maybe I would kind of like generalize that out a little bit of, does anyone have a unique story about, either needing to convince, an employer of how those skills were transferable and either that they got it or they didn't? Any of those as being kind of a useful anecdote here. Yeah, Matthew, go ahead.
Yeah, so I definitely was recently looking at the job market because, as some of you may have noticed, the DC and government jobs have been very volatile lately. So fortunately, I managed to weather that storm. But I was doing applications, and I ended up putting, got a PhD in astronomy. And during an interview, the person was like, "Well, I could put a telescope in your office, but that's not really, you know, useful at all." And so I had to kind of, take a step back and be like, well, no, a lot of the skills with astronomy of image analysis, signal analysis, and just being able to collect messy data, evaluate it, and come up with a conclusion. So it's almost like you don't necessarily want to come and start off saying, I am an astronomer, or I am a, PhD in astronomy. It's, I think, more valuable to and more useful to kind of put forward of what your skills are, saying, I have used one of the most advanced radio interferometers to, collect signals, analyze them, and put them forth in a cohesive conclusion to evaluate data. So I am capable of, using coding to evaluate big data, and that is something I can bring to your company. So I think it's better to look at the skills and capabilities that you have earned as getting your PhD.
Yeah, I know this is definitely something that we hear quite a bit from external speakers talking to grad students and postdocs here at CIERA, is, that there's a difference between an academic CV where, the listing of all of your papers really matters, versus, kind of an industry-facing resume, which, right, like is trying to break that down for, for folks, that you collaborate with large teams, your coding skills and capabilities, even just like data analysis and messy data, being able to bring that down, break that down and put that in that context is definitely something that we hear over and over. Hannah.
Yeah, I think it's a great question. 10 years ago, it was easy. Everyone, you said you did astronomy, and everybody was biting your hand off to talk to you, especially recruiters. That industry has collapsed since, and obviously with the rise of AI filtering on job applications, that makes it a bigger challenge. I've, similar to Matthew, found myself in conversations where people just don't really understand what astronomers do. I think it's critical to have, you need to look up some good examples of what a CV looks like that isn't an academic CV, because they ask for very different things. But you need to be able to translate what we do and the skills that you pick up in astronomy, physics degrees and in academic paths into the industry that you're particularly looking for. So, for example, my experience was, generating a lot of telescope time. I calculated the revenue, the equivalent monetary cost, that is, of time generated, and put those numbers on my CV. So the value I can bring in terms of massive amounts of money, and not just grant proposals, but actual just pure hours, that really helped. I mean, for me personally, I got very lucky that my current boss, his best friend, was an astrophysics researcher. So when I said what I did, she knew what that meant. But I meet people all the time who are surprised by that leap from astrophysics to business. And so it's about being good at communicating those skills, the AI skills, the coding skills, the scientific analysis and and kind of critical thinking that you develop. Get that into a language that works for the industry that you want to work in, and then learn to be able to do that quickly because people do not have time for a 30-page academic paper. That would be my advice.
Arena.
I think the best advice I received about job applications, not in academia, were first rearrange your resume for the job you want. When I was ready to apply for jobs, I thought, great, I want to be a data reporter, but the job market was tough in June 2020, so I applied for 20 jobs in a lot of areas, including health reporting, science reporting, jobs that maybe I thought I didn't have as much experience in, but I could kind of stretch myself and I had some skills. And so when I applied for each job, I rearranged my resume slightly. I would, bring to the top certain experiences that were maybe more relevant for the health reporter role instead of the science reporter role, for instance. And then the other piece of advice was that your cover letter is an opportunity to tell a story that your resume can't. So a resume is a bulleted list. Your cover letter is a place where you can let your voice shine, but then also connect the dots for people. So it's also want to ask the question about, do you have a gap between graduate school and postdocs and industry jobs, or did you have to take time off, or did you take a gap? Just there. Everyone's story is a little different, and so use your cover letter as an opportunity to tell a compelling story. And it's also a great place to really emphasize, I may have a degree in electrical engineering, and that may not be normal in a newsroom, but here are the skills that I picked up, and here's what I can bring to this job.
Yeah, Gentile.
Yes, I think what Matthew, Hannah, and Irina mentioned are very good regarding like that's what I discovered when I apply jobs. I really need to like literally toss my academic CV because it's not useful at all. People don't care about how much publication, how much citation you have, and you really need to tailor your CV and to know. Maybe this is also one of the thing that you could do, like when you are undergrad, maybe just get to know more about like the language of the job industry, what they need, like, and here you can like transfer like really the language of the job market, like what kind of skill you need and what kind of skill you gained through your whatever PhD postdoc, you can translate into like just as Hannah mentioned, like you transfer the money, like how much money I get, I gain through the telescope time. But another aspect is like you have to realize, and a lot of times when you are in academia for a very long time, is you are in the bubble of academia. Like your world is full of is pure science, and you don't realize what is going on outside, and you're just thinking, oh, astronomy is just the most important thing in the world. But outside, people rarely know what you are doing. Like people will think, oh, are you doing astrology or tell me my fortune? Like, there's a lot of time you get this. So in my experience, my hiring manager was a bit intimidated. That's the most common response you will get. That, oh, you are doing astrophysics. Oh, it must be very difficult. And what you're doing, I don't understand. Oh, maybe you are too complicated for my job. And a lot of times maybe there's this disconnection. And I think it's also important that you have to show that you are genuinely interested in this job. Like you don't, it's not like something that you just want to dabble and you will get bored of. So actually, my hiring manager was literally asking one of my colleagues, that's asking her like, will I get bored because of the job is so like detached from like what the levels astrophysics required, but actually it's not. So there's this kind of the conception, like misconception, like how or people just generally don't know much about astrophysics. So I think this is important to also like bridging this gap to let people realize like you are generally to show your genuine interest in the job. Like this is also important to realize there's the gap of understanding. People don't understand what astrophysics is actually doing. So that's very important. Yeah.
Thanks, Gentile. Other questions in the room? Okay, then I have one. So I think you all have made a pretty, all the panelists have made a pretty convincing argument for, for your paths and having gone through PhD and the skills that you've picked up have certainly been applicable in the careers that you've had. So Lainey from Davidson kind of puts a finer point because I know, we're talking to folks, undergrads in their REUs who are maybe trying to decide, ooh, this like even one of your specific careers like sounds really good. Is it worth to do like a grad school route or just trying to go down, one of those like and go after the specific career in itself. So, Lainey specifically says, would you advise a student against pursuing a PhD if their goal is a career like yours? Or on the other hand, in what scenarios would you strongly encourage them to do it? Any of the panelists want to take that one?
I'm happy to kick this off because I have strong feelings about a PhD. Um, so to be clear, I don't think that, well, first off, PhDs are not normal in journalism. So, like keep that in mind. This is an industry where if you wanted to go into journalism, and depending on the kind of journalist you want to be, even as a data reporter, a lot of us don't have PhDs. So it certainly isn't necessary. Um, that being said, it has been useful. And I think above all, what it sort of signals is that I really know how to learn, which everyone here knows how to learn. But I think if you've done a PhD, like it's another level of research and learning and being able, as I said earlier, to deal with sort of maybe vague or ill-formed goals, which is true of a lot in real life. Or sorry, real life being not academia. Sorry, I should just stop trying to correct that. That being said, I think that in hindsight, the advice I give the most to people considering PhDs is I think you should know exactly what you want to study and maybe even better with whom. Because a PhD is long, it can be isolating. It's very much an individual pursuit. And if at any point you have doubts about whether you're very interested in the topic, like I did a PhD, half of it was in biophysics. And to be clear, I think it's fascinating. But do I stay up at night debating with people about whether protein makes this motion or this motion? I do not. And meanwhile, like everyone else in my lab really cared about that. So I think basically like if you know, I think a PhD is good, especially in these times where funding is uncertain. There's so much uncertainty, there's so much emotional sort of instability and risk of emotional instability that just know what you want. Otherwise, maybe look into other jobs where you can get hands-on experience.
Yeah, and Julie.
Yeah, so like I think like for what I do, like I don't necessarily need a PhD, but it did help me get to where I am. And I will say, as like a hiring manager, especially in like data science jobs, it like was really hard for me. Like it was like usually we would like actually filter out folks that didn't have at least a master's because like I think in undergrad you do a lot of like really important like knowledge base like setting, right? And like kind of a foundation of knowledge, but you don't necessarily drive like scientific research yourself, right? And I think the REU program is like really excellent because it's kind of like this unique opportunity to do that. Like you might have a capstone or something to like get your undergraduate degree, but like in your master's is really like the first time where you're sort of like driving something yourself, like in a like I think a soup to nuts way that like does helpfully like demonstrate a certain skill set and like kind of like put you through your paces, like in a way that I think is important. That being said, like, does it need to be in astronomy? No, it doesn't. But like something that like I think is important is like having demonstrated like an ability to like do like analysis or do like whatever. And it's not just like that, like the math or like the coding, but like applying it to like a particular subject matter. Like it could be astronomy, it could be like biology, it could be like legit like computational social science, right? Like all these different kind of fields, but like it's not just about knowing the math and the methodology. It's like about knowing the kinds of questions and like the subject matter in these fields, I think is like important. So it's like in a lot of these roles, I do think it's actually a master's kind of like is sort of a very helpful.
Yeah, we'll do Matthew, then Hannah. Matthew.
Yeah, so to kind of reiterate some of what's been told, I think it's very important to look at the industry that you might be interested in first, see if a PhD is useful or not. Personally, I feel if you're on the edge of maybe a PhD would be beneficial, at least to me, I feel like it's a much easier transition going directly from undergrad to a PhD than going into industry, working for a while, and then realizing, oh, maybe I need to go back and get that PhD, just because you're already in the habit of going to classes, getting, taking tests, doing problem sets. Whereas like if I wanted to go back to grad school now, like I could do it, but I might not like it as much because I'm just, I've been out of that habit of my mentality. But if you are in the, kind of to reiterate what I believe Julia was mentioning, yeah, there are also a lot of careers where a master's can be very, very useful. And so this might be something that you or Mark might be a little bit more knowledgeable on, but there's definitely some universities where on your process to getting a PhD, you get a master's. And then so that gives you the opportunity of, all right, maybe I have my master's and now I pull the eject and decide to go into industry. But that's something you really should be careful about when looking at your grad, because I know some schools will also, when they accept you into a PhD program, they're expecting you to finish a PhD. And so they might not give you the master's degree. Like you might get a PhD and a master's, but you get it when you get your PhD. So be careful when you're applying to graduate programs. Otherwise, there are also schools that do just a master's, and you can kind of, in a way, do what I did was, I bombed the physics GRE initially because I did not know how to properly study it. So I went to DePaul where they only had a master's program. And so that's then and there were quite a few people there who were like, I'm not sure if I want the PhD or not. So they went there, got a master's, and then while we were there, we studied properly this time how to take the physics GRE. And then quite a few of us went on to get PhDs. So that can be another option if you're on the fence. Go to a master's program, get a master's, and then it makes the first couple years of your PhD program a lot easier if you're coming in with a master's.
All right, Hannah.
Yeah, I mean, I would say I loved my PhD. There were a lot of difficult bits in it, but I got to travel the world, do great science, and make friends for life. But I've always said to my students that it's not for everyone. They're definitely my job now. And I'm the only person I know with a PhD who does it. It makes me stand out a little bit when I'm kind of talking to people at conferences. They remember me as the professor of astrophysics who now does this. But it certainly has meant that I've spent longer doing astrophysics and maybe a less further ahead in terms of positions in my career now. And I think it's just a choice you have to weigh up. There's a lot of value to a PhD, as others have said, but it's definitely not for everyone. Think about the financial decision on that. I think a lot, depending on where you're doing your PhD, in what exactly specific subjects and subsection, and also the mental health side of it. Choosing, if you do choose to do a PhD, the right program and the right advisor is critical, because that's the thing that changes it into an experience that you'll always remember fondly, or an experience that you wish you hadn't done, I think is the kind of key thing.
Yeah, and Chintao.
Yeah, I think PhD is difficult. It's an experience of your life. That's probably the one of the experience that's very special. So to me, I think it's kind of reversed. You shouldn't think about like I need to look for job in like to be able to look for job, I need to get a PhD. I think this is not a proper way of thinking. Like if you want to look for, if your target is looking for a job in the industry, then probably PhD is not is not a means to the end. And PhD is something you should really like, you should really enjoy. If you should really be like genuinely interested in the topic, because that's a significant time of your life, and that you have to devote yourself fully in the topic. It's difficult. It's really tough, and you have to have the passion to support you. I think you have to really truly love the topic to be able to go on that journey. But looking for a job is another, like, for me personally, it just happened to be in my life. I need to look for another job. Then I need to transfer what I learned from my PhD into my career choice. That's a different story. But to me, maybe I have an unpopular opinion that, to me, I think, like, as Hannah mentioned, a PhD is personal. You have to weigh in a lot of other personal factors. But in the end, it's really, it's not about looking for a better job. It's another thing. It's totally different thing. So that's my opinion.
Great, thanks. And maybe to bring it home, looking at the clock, I'm very curious to hear about kind of how you're all in your current careers kind of intersect with AI. So AI is, all the talk, all the hubbub. I'm curious to just kind of, maybe we can do a quick go around of, kind of level of impact on your job and in your industry, and positive and or negative aspects of that, and kind of seeing where things are going and like what the current trajectory is. Is it something that you see as mostly a positive, or are there some challenges? And maybe Arena, I'll pick on you first, since you did kind of explicitly talk about using agents and using the tools.
Yeah, it's been I think it's been pretty it's a big deal in the news industry. And I think we're still grappling with not only what tools to use, but also how do we make sure that we have job securities so that AI doesn't replace us. So that's sort of a labor and union kind of thing, but it's also very important. As far as using AI in the newsroom, we are being encouraged to try out new tools. We have been using it for things like scraping, also classification, but we have also in parallel had to be very clear about when and how to use AI, because we certainly don't want reporters to say, oh, well, Gemini said this. Did you check the sources? Like, was it actually citing an actual paper, or did someone actually say that quote? And then I think the other really important thing to consider with AI is oh, sorry, just lost that train of thought. And yeah, it has been, especially since the work that we do is all about organizing data and extracting trends, which AI seems to be pretty good at. It's been a little nerve-wracking. So yeah, sort of ups and downs. It's been useful, but it's also very much having us making us think about how do we create guardrails to ensure that we are doing the best work we can, and I'll pass it on to the next folks.
Thanks, Serena. Julie, maybe because I know you were also talking about even doing red teaming of kind of your perspective on the AI innovation.
Yeah. So like the organization that I work for, if AI went away, this organization would go away. And like our mission is really to like try to understand how especially generative AI is being used in like particular applications, and like if it's doing okay or not. And the answer is usually not. So, for example, we've worked with like education technology companies who wanted to create like AI assisted tools for students. And so, like, a lot of our work has been working with like people in the education space and the technology space, and even like interfacing with students and like how they're like using the tools and having them experience like this tool and see if it's doing things that like the organization that we're working with like expected them, like how it should work or not. And so then what we'll do is like we'll do an analysis of like the responses and like the prompts that get sent to like the different LLMs, and then like offer recommendations about like things that like they could do to like make the outputs like better or like you kind of like more akin to like what they wanted to do. So it's like in like a lot of like high stakes domains like healthcare and like education and like whatnot. I think it is really important to like have like organizations like mine and like other ones evaluate how these systems are working. In my like day to day, like I do use like AI assisted coding, like Claude Code and like whatnot. And part of my job is to try to like understand like how do these things work, right? And how do we set up studies to like better understand the not just like the model itself, but like the system in which the model is like living, because that also impacts like how people interact with it, and like how people interact with it changes like the outputs. The outputs are probabilistic, which is like always like a big challenge in terms of like, you know, being scientific. And so I think like even if there are misgivings about AI, it is important to not just say like to opt out of it. I think you have to like kind of really try to like understand it. And like what we haven't done as an AI field, I think, is understand it from like a particularly scientific perspective. And so that's like one of the things that I do in my day job is like, how do we make sure that like we have a scientific understanding of like how the stuff works, because it's everywhere, it's ubiquitous. And so these systems that are helping push decisions are like important to like take apart.
Sure. Hannah, Chantao, Matthew, anyone else wanna chime in?
Yeah, I can add something. So, AI is a big part of what I do. I'm leading a lot of AI projects in my day to day. I'm also dyslexic, so AI note taking has been a revolution in my life. Really, really like massive in terms of helping me just be better and more efficient at work and capture things that otherwise might be lost. But it's also a massive challenge. You know, every single vendor out there is saying, oh, we can do, you know, what I do with AI. You know, you don't need to spend any more money. So some of our clients have gone down some pathways of spending a lot of money on AI and AI solutions that they don't really understand and haven't really achieved the goals that they want to do. And I think it's both a blessing. Like I've built things that I had been thinking about for years that I've now done in a day. It's been great to kind of code and but I think one of the key is having that expertise in data analysis and coding and other things that you kind of get from having a physics astronomy background allows me to kind of assess how good the AI is doing things and kind of guide it. And that's like weaving that AI into the tools that we sell and the expertise. It's been critical in our jobs because there's also a lot of people just out there using it for whatever and getting themselves into all sorts of kind of messy places. So I would say my biggest advice around AI is become an expert. It's changing every week. And a lot of people, a lot of important people in a lot of big positions do not understand it. Like with the background and in your degrees, you know, understand how LLMs work, how they're being implemented, some of the history, some of the ethics, and some of the kind of powerful things, but also a lot of the limitations and the dangers. That'll give you an edge that a lot of people don't have.
Yeah, and Matthew.
Yeah, I've had a kind of a weird, interesting, like two-pronged approach. Or like in terms of actually using AI, I found that I've used it very, like not very much. Like it's useful for coding, but like I can't really use it to, you know, I can't have it read some of my documents and be like, give me a summary or compare these documents or oh, look at this data. And so we get this weird juxtaposition where we'll have like leadership be like, oh yes, AI, go, 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 we have to use it. But then like our IT or our lawyers will be like, no, 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 hold on. You can't, you know, you can use it, but you have to use it in this very, very small box to make sure that we don't get into any legal trouble. And so that is, I know, kind of a unique thing with the type of data and work that I do. But on the flip side, we've also been paying attention and learning about and studying AI for years, seeing, you know, we saw that this was coming. We saw that systems are going to be using AI, and so we looked into, you know, making sure that we know how to evaluate them. And you know, kind of reiterating what Hannah was saying, that there's a lot of leaders and that are really pushing for it, but not necessarily understanding the caveats of it. And so, like your training data set is super important, and a lot of people don't appreciate that. And so it's just like a black box of, look, we have this AI, it classifies things, and it's like, great, but if you only trained it in like the city where, like for example, like self-driving cars, it's like, all right, they work great where you have like paved, well-marked roads, but you put it out in like a gravel road in the countryside, with some sleet, maybe it's not going to work so well. And so the quality of your AI really depends a lot on your training, and a lot of um, people who use AI might not appreciate or even know what they trained it on. They're just like, oh, well, we got this thing off the shelf and we use it. And it's like, great, but you don't understand the uncertainties and claims of it. And so if you can learn those skills and just learn how to understand AI, I think that'll definitely give you a step up, so that when someone, says, look, I got these results from Gemini or whatever, you're like, okay, but here are the likely problems with that. So here, let me help you improve what you got from the AI.
And Chen Tao, bring us home.
Yes, so I think like AI, specifically the large language models, is the topic in the programming industry. From my personal experience in our company, we have, because of the access, like for example, Cloud Code and Codex, those tools, the number of we have a lot of internal tools that we built for the use of ourselves, and the number of these internal tools has exploded because of Cloud Code or whatever. But I realize it's getting hard to keep up with the speed to review. Like, are those tools built in good quality or not? And it's just it's so easy to generate all those hundreds, thousands of lines of code, but it's very hard to keep up review the quality. And maybe it's not possible to review anymore. And then people even talking about just using AI to review itself. It's kind of it's very, very difficult to. It's uncharted territory. And on the other hand, I also realized when I start to touch some areas that I'm not I don't understand much of, but I can actually do things with AI. But I just using that for a while, I realized I didn't learn anything. I learned basically nothing by using AI. I found this is so dangerous, from my perspective, because I'm doing things, especially imagine if you are a computer science degree undergrad, you can just use AI to do whatever task, but you are not learning anything. That's really I think that's really creating kind of sometimes creating this illusion. Maybe it's like Google, you Google the answer and you thought you know the answer, but you really don't know. If you lose the connection of Google, if you don't have access of AI tools, then you realize you don't know anything. So that's very dangerous, I think. But on the bright side, for example, I still have a passion in astronomy. So in my free time, I can accelerate my, maybe I can use maybe 10% of my, half of my free time. I can do some astronomy research even. I can use my Cloud Code and Codex to write my script. It probably will take me 3 weeks, and now I can just do it in 1 day. So that's fantastic for me to do something that's impossible. So that's the bright side. So it's kind of a mixed bag, and it's a lot. There are a lot of uncertainties that we're still trying to figure out. Yeah, thank you.
Well, panelists, not just on the AI question, that was great to hear such a broad kind of range of perspectives. But really, as we kind of wrap up and close out here, really appreciate you all taking the time. It was great to hear about all of your careers and all of your insight. And so, yeah, on behalf of all the students, we really appreciate you coming. So thank you so much.